so I'm going to take you through how to solve a polynomial inequality first of all, and then we'll do like one more example of a rational inequality. Now this kind of thing you do a lot in calculus class, so we like to make sure we can get students kind of comfortable and see how this works in this level of a class. So the first thing that you always want to do is you always want to have, for your first step, you always want to have one side of this inequality being 0, just like you would on an equation. So we already have that in that problem. So what we're really going to do on this is we're going to just start by solving this equation, which of course you can do this in your head. What's the solution of that equation? 3 and negative 2, right? Okay, so we're going to go ahead on our number line and we're going to put a negative 2, then we're going to put a 3, kind of like that. So we're going to do this basically algebraically first. So we're going to do a sign chart on this, and this one is real simple to do. Okay, so what we're going to do is we're going to do just like we did on the last problem, we're going to do test points. So let's pick a test point out here. What's a good number? Negative 3, right? Plug it in to what we're doing. So we're going to have negative 3 minus 3 over negative 3 plus 2. Okay, all that's going to do is give you a negative times a negative. That's a positive, so what that means is that you're above the x-axis. Okay, so if you were to graph that, you would be in a region where the graph's above the x-axis. Okay, let's do the same thing here. Give me a test point between negative 2 and 3.
0.
You read my mind. 0 is the best one. Okay, it's the easiest one. So we have 0 minus 3 times 0 plus 2. So you have a negative times a positive. It's negative. What does that tell you about your graph? That you are below the x-axis, right? All the y values are negative, so they must be below like that. That's what that means, okay? Now we do the same thing with the other region. You pick a number bigger than 3, like say 4, plug it in, you would have 4 minus 3 times 4 plus 2. That would be a positive times a positive. So what does that tell you about the graph? We're back above again, okay? So that's how that would go. So really all you got to do to solve this problem is, since you were looking for where it's greater than 0, well, you were looking for where the result were positive. So your solution is going to be in this region and this region right there. So we just write that in interval notation. So what we would say is this region here, we would say negative infinity to negative 2. And would you use a bracket or a parenthesis? Parenthesis. How come parenthesis? Because that's a greater than. That's excluding that. And then you would say union, and then you would say 3 to infinity like that. That's how you would write the answer to that problem in set builder or in interval notation. In set builder notation, you just say set of x, and you just write the inequalities. This is going to be x is less than negative 2, or x is greater than 3. So you just name the inequalities like that. So that's the solution of the problem, okay, like that. So that's how you would do that with a sign chart, which is what you're going to do most of the time. If it's fairly easy to factor and solve the equation, that's the way you go. Now graphically, it'll go like this. Okay, now without a graphing calculator, I want to just show you that this sign chart tells you exactly how this graph goes anyway. So the solution of this equation is 3 and negative 2. Okay, and we've already learned how to do this. So like you have a point there at 3, you have an x-intercept at 3, you also have an x-intercept at negative 2, like this. Well, okay, isn't that a parabola? If you multiplied that out, if you multiplied that equation out, you would have x squared minus x minus 6. That's a quadratic equation. It's a parabola. So this would tell you what this looks like. You would be above the x-axis there, you'd be above there, and you'd be below there. So roughly that's what that graph looks like. That's not a perfect graph, but it's a sketch of that. So like if you put this in your graphing calculator, I promise you that's what would come out. So you're looking at where the y values were positive. That's why the answer to this ends up being in this region and that region like that. Does that make sense? Okay, so there's a connection between that sign chart and the graph, and that's what you want to make sure that you understand. Okay, everybody with me there okay? Okay. All right, now let's do this second example. It's the same thing, but it's got one different twist to it. What's the first thing you think you should do on example 2? Yeah, move the 12 over, good. So we'll have x squared plus 7x and then plus 12 less than or equal to 0. Now you want to factor. Most of these problems are set up so you can factor them. So you would have x plus 4 times x plus 3. Now that would be less than or equal to 0 like that. Okay? So what are the two solutions? -4 and -3. Good. Okay, so that means in your sign chart, you have -4, you have -3. So those are going to be the two regions, or the three regions you're interested in. Now it's just test points. And it's easier to plug the test points into the factored form to figure out whether it's below or above the x-axis. Okay, so let's use like -5 as our test point here. Plug it into your factors. So you would have -5 plus 4 times -5 plus 3. Okay, that's going to give a negative times a negative. It's a positive. What does that mean? You're above the x-axis, right? All of your y values are positive, so that means your graph is above the x-axis, okay, like that, okay? Let's take a test point between -4 and -3. Let's do like -3.5, okay? If you plug it in, you would have -3.5 plus 4 times -3.5 plus 3. So you would have a positive times a negative. You have a negative. What does that tell you? You're below the x-axis. Okay, you've got a parabola on this just like the first problem. Okay, take a test point bigger than -3. I'll use 0 anytime I can use it. So I would have 0 plus 4 over 0 plus 3. That's a positive times a positive, so it's a positive. Therefore, you're above the x-axis like that, all right? So this time it's different. Okay, what am I looking for this time? Since it said less than or equal to 0, what are you looking for? You're looking for where it turned out to be negative, right? So you're looking at this region here. So the answer to the problem is going to be between -4 and -3. Now you're going to have brackets or parentheses? Right. Have brackets because it's got the less than or equal thing, right? So the region that you're looking at is right there. Okay, that's actually a graph of the solution like that. So what you would say is just -4, 3. Set builder notation, you say set of x. And you have to say this like this. You have to say -4 is less than or equal to x. It's less than or equal to 3. We've seen that before. That's how you write that x is in the middle of two numbers. So you're in the middle of x, and that should be a -3. I missed my negative on there, didn't I? So let me put that negative on there, so that's how that goes. Okay? Is that reasonable? Okay? You're going to do this in calculus. A lot of you have had calculus before, so you did like found where functions were increasing and decreasing. You learned about concavity. You really work with inequalities like this where you do sign charts. Okay? Now graphically, hey, we know what the graph looks like, so basically what you'd end up having is all I want you to do is just a very rough sketch on this. We have x-intercepts at -4 and -3, and then this graph is going to do something like that. Okay, that's only a sketch, but that's good enough. Okay, so that would tell you that what you're looking for is that little piece right there. That's the idea. Okay, does that make sense? Okay to everybody? Okay, so there's a lot of the idea of solving an equation by factoring, and there's that sign chart. Yeah.
So I was asking on the day that we went over this, but why are we looking for whatever is below the x-axis?
Okay, because the original inequality is less than or equal to 0. So you're looking at when it's negative. The previous problem was greater than 0. That's why. Okay? Yeah, you're always comparing it to 0. Okay? Okay, so I think the other things on here we did last time, I think I'm going to do, we want to work a little bit with rational inequalities. So let's go do one more like this. I want to kind of give you an idea of all the little nuances of the problem. So how do you start example 4? Move to 6x. Okay, I think we did the one above last time. So you can get that caught up. You can watch my video if you want to. So that would be 4x squared minus 6x plus 9 like that. Okay, and then that's going to be less than 0. Okay. Well, okay, this one I'm not sure if it factors. I'm going to try. I can't tell, but let's try 2x and 2x there. Let's try a 3 and 3 there to get the 4x squared and the 9. And then I think 2 minuses is the right way to factor that. So this one would actually factor as 2x minus 3 times 2x minus 3 is less than 0. Okay, now I'm going to write this like this. So we have 2x minus 3 squared is less than 0, like that, okay? So what's going to happen on this one, and you got to be kind of careful about what the situation is in here. First of all, on your sign chart, you're only going to get one answer to that equation, right? You're going to end up getting x is equal to 3 over 2. So on your sign chart, you just want to put a 3 over 2 there, and you want to go like that, okay? Now, this one right here, you want to reason out what's going to happen on this problem. Now, you can go ahead and crunch out the details, but I can show you that you could bypass this anyway. So if 3/2 is our only answer, then a test point there would be like 0, and 1 there would be 2, because 3/2 is 1.5. Okay, well, here's the thing. If you plugged in 0 in there, you'd have 2 times 0 minus 3 squared. What happens if you square something anyway? You get a positive. So that's going to be positive right there, right? Okay. What's going to happen if you plug 2 in? And see, you don't have to do this. You can do this in your head, because well, I'm going to square something anyway, so I'm going to get positive. So what this means then is the graph of this is above the x-axis, but it's on the x-axis at x equals 3/2. That's what you get from that sign chart, is you get this. So remember, what you're trying to solve is you're trying to tell me, where is this less than 0? Did it ever turn out to be negative? No. So what's the answer?
It doesn't exist.
Yeah, no solution, right? Okay, because what you're looking for, if it's a less than or 0, less than 0, we were hoping we'd find a place where you're below the x-axis, and we're not. See, that's the thing. So what we'd say on this, we just say no solution. Okay, you just put an empty set. You can write out no solution. In interval notation, you don't put anything. You just say empty set. Okay. So let me show you what would happen if you put this in your graphing calculator. You can just watch this. You don't need to do this if you don't want to. But the idea that what you would come up with if you put this in your calculator, and I'm just going to put it in the original form, where I have 4x to the second, and then I had, I think, minus 6x, and then plus 9. So let me show you what happens on this. So if I do that in the standard window, this is going to do exactly what the sign chart told us on this. Okay, let me make sure I got that in there right. Do I have all my signs in there okay? Yeah, I do. Okay. So what I'd end up having on this then is, if I get that graphed in a standard window, notice that that thing was always above the x-axis, wasn't it? Okay. So what's happening on this graph here basically is, after you get that factored and everything, then that's always going to be above the x-axis. So your graph, you can just sketch a little graph on this. It doesn't make any difference. The idea would be that you're always above. Okay, so it's never going to be below. So that's how you would solve that graphically, is just look at the graph like that. Okay, then you got it. Okay. All right, does that make sense to everybody, how that works? Okay. All right, so it's kind of the same idea, is by doing that, we ended up with the sign chart just told us we were always positive, so there's no solution to that problem. Okay? All right. What if the problem said greater than 0? Then what would the answer be? All real numbers, exactly. Okay, then everything would work. Okay, so that's the idea. So that's a kind of a special situation that you'll encounter a little bit when you're working on these problems. Okay? Okay, we're going to need to finish up here with a couple of more rational inequalities. Now, if you can do a polynomial inequality, a rational inequality is almost the same thing. It's got a little twist to it. So this one's already in a factored form. So what you want to do on this, if it's in a factored form, is you just want to figure out, well, what makes the numerator 0? And you're going to do this in your head, of course. And what makes the denominator equal to 0? Okay? So what makes the numerator 0 is going to be 3 and negative 2. And what makes the denominator 0 is going to be 1. Okay? So let me ask this. What happens at 1? What are you going to have on your graph? You're going to have a vertical asymptote, right? Okay? But remember, a vertical asymptote is where that rational function is undefined. So what we want to do on this when we put this together, let's just put all the numbers in the right order. So we have a negative 2 here. We have a 1 here. And then we have a 3 like that. And then what I like to do is just kind of maybe make a note to yourself that that's a vertical asymptote. Sometimes I tell students to put undefined there, so it's really loud and it tells you at the end of the problem that that can't be a part of the solution because it's undefined. Okay, then these things right here are actually x-intercepts. So that's an x-intercept. And this part right here is also an x-intercept. Okay, so it goes like that. Okay, now what we're going to do is the same thing we've been doing. We're going to do test points. Okay, so we're going to go ahead and crunch that out one by one. So let's take a point here like -3. Crunch it out. Do as much in your head as you can. You'd have -3 minus 3 times -3 plus 2 all over -3 minus 1. Okay, so that looks like you'll have a negative times a negative in the numerator over a negative. That's a positive over a negative. That means it's negative, so that means you're below the x-axis. Okay, and I'm going to do these fairly quickly because these things you can process in your head with a little practice. Okay, let's take a test point here. Let's use 0 there. Okay, plug in again to the original. You would have 0 minus 3 over 0 plus 2 all over 0 minus 1 like that. So that looks like that is a negative times a positive over a negative. So that is a negative over negative, which is a positive. So that means you're above the x-axis like that. Okay, see how I'm doing the same thing over and over again on these problems. Okay, let's use a 2 here. Go ahead and plug the 2 in, and you would have 2 minus 3 over 2 plus 2 over 2 minus 1. Okay, so that's going to give a negative times a positive over a positive. That's a negative over a positive. It's a negative. Therefore, we're back to below the x-axis like that. Okay, and then finally, if we go out here to like 4, you would have like 4 minus 3, 4 plus 2 over 4 minus 1. So that's a positive times a positive over a positive. That's a positive, so therefore above. Okay, now I'm doing those things pretty fast, but those are pretty quick calculations. All right, everybody understand what I'm doing okay here so far? Okay, so what we're going to have then is your solution is, what are you looking for if it's greater than 0? You're looking for where it's positive or above. So your solution falls in those two locations right here. Okay, so what you would end up having for your solution is you would be, in interval notation, you would just say, okay, between -2 and 1, and you would exclude those because it's greater than. Okay, then union, you would be 3 to infinity like that. Okay, so that would be the two regions that satisfy the conditions of that inequality. Okay, as far as set builder, you would go like this. You would say set of x. You would say -2 is less than x is less than 1. Again, that would be this region right in here. And then the other region, you would just say, you can say, or x is greater than 3. Okay, so that's how that goes. All right, does that make sense? Okay, all right. Now, we're not going to do anything with the graph on the calculator. We're just going to sketch it because, see, once you do that, that sign chart, you're getting the sketch anyway. So what we have on this problem, basically, let's kind of get everything pretty well put together here. So you have a vertical asymptote at 1. Okay, so you want to just kind of sketch in your vertical asymptote because we know that's where the function's undefined. You had an x-intercept at -2, and you had another x-intercept at 3 like that. Well, here's what the graph's going to do. Just look at your sign chart. So you're going to be below like this. So you're going to have that. You're going to be below, then you're going to be above, then below, and then above like this. Now, the other thing that you want to do on this is, this one is an example of one that's got a slant asymptote to it, so it's a little harder to get a graph on this without doing the slant asymptote. So what I'm going to do is I'm just going to go to my calculator, because the slant asymptote, I'm not going to deal with that very much. Okay, so I just want to put this in like this, and you got to be careful how you put this in. You'd have to have double up on the parentheses. You'd have x minus 3 like that, and then x plus 2 like that. So you got to get the whole numerator in its own set of parentheses, and then the denominator also has to be in a set of parentheses like that. So this one's got a slant asymptote, so unless you find the slant asymptote, it'd be a little hard to put this together. So I'm going to just do a zoom 6 just so we can get a rough picture of how this graph goes. So what you would end up having is this. You would end up kind of going through like this, kind of approaching that asymptote and going like that. And then over here you would be going kind of down like that. Oops, It's hard to, you can see the slant asymptote in here. So it's kind of going down like that, and then kind of down like that. Can you kind of see how it's slanting? Okay, so what's happening? How do I know it has a slant asymptote, by the way?
Because
The degree of the top is bigger than the degree of the bottom. The degree of the top is 2. If you multiply that out, you have a quadratic, so it's going to have a slant asymptote like that. So that's how that goes, all right? Okay, does that make sense? Okay, all right? Okay, and I want you to be able, again, to know how to do these both ways. I'm going to do one more of these, and then we'll take a break. This one's the one that's probably the hardest to do just because of the algebraic process you got to deal with here, okay? First thing you got to do on this is you got to get one side being 0. So we're going to write this as 1 over x minus 2 over 3x minus 9 is less than or equal to 0 like that. Now you're going to put that together. You got to get a common denominator and put that together before you even make a sign chart, okay? So the idea is you always want to have just one fraction put together, okay? So we did this kind of way back at the beginning of the semester. I'm going to factor a 3 out of the bottom, so I have 3 times x minus 3 like that. Okay, now I need to get a common denominator. I got to make them look exactly the same way. So the way I look at this is this denominator here needs an x minus 2, doesn't it? It needs one. So what you need to do is put an x minus 2 there, and then put 1 in top like that. You want to make the denominators exactly the same. Okay, what is the one on the left side? What does it need that the other one has? It needs a 3, and it needs an x minus 3, right? So put a 3 times x minus 3 there. Okay, just make it so. Make those denominators look exactly the same, all right? Now you have to work this out and get this put together. So this part right here you would have, I'm going to multiply that out, so that's going to be 3x minus 9 there. That's going to be 3 times x minus 3, x minus 2 there. Okay, bring your minus sign down. Okay, and then multiply this out, so that's going to be 2x minus 4, and then all over 3 times x minus 3, x minus 2 like that. Okay, you guys see what I'm doing? Okay, you have to put this together before you can make a sign chart and analyze this then. So what you're doing, you want to be kind of careful about this, is of course your common denominator is 3 times x minus 3 times x minus 2. Now if you put together this numerator, you got to be really careful about this. What you're really doing is 3x minus 9 minus 2x plus 4. Okay, that minus sign is subtracting both things, so a lot of times I see students slip up on there all the time. You're subtracting both the 2x and the 4, so you'd end up getting x minus 5 would be what you would end up having in your numerator like that. Okay, so actually what we're going to do when we solve this inequality is we're going to base our sign chart on that. Okay, do you guys follow everything I did with the arithmetic there okay, including the minus sign? Okay, watch that and make sure you don't have any problem with that minus sign because that'll mess everything up. Okay, so here's basically what we're going to do. We're going to do our sign chart. I'm not going to do the graph on this one. I just want to do the sign chart on this one. The graph you can put in your calculator if you want to. Okay, so tell me, how many vertical asymptotes does that have? 2. What are the 2 vertical asymptotes? 3 and 2, right? Okay. How many x-intercepts does it have? 1. Okay, the x-intercept comes from looking at the numerator. Okay, because remember, you set the function equal to 0 to find that. So what you would end up having on this is you would have an x-intercept at x equals 5, and then you would have vertical asymptotes would be at x equals 3 and x equals 2. Now, it's real important you are able to distinguish between the asymptotes and the x-intercept. Okay, so what I'm going to have you do on this, we'll kind of spread this out. We have x equals 3. I'm going to put a bunch of undefines there. I'll make it real loud and just make a note that that's a vertical asymptote. Okay, the other vertical asymptote I had was at 2. So let me actually change this like this. I need to put this in order. So that's going to be my 2. Then over here I'm at x equals 3. That's another vertical asymptote. So I put undefines as notes to myself. I'll show you why in a minute. And then x equals 5 is going to be like an x-intercept. So we're going to go like that. Okay? Now, what I want to go ahead and do on this problem now is instead of doing sign charts, I'm going to show you something that's a little bit different you can do. I'm going to put this in my calculator, and the calculator will tell me the result of the sign chart. I mean, I want you to know that. So if I put in like this, and you don't need to put it in, just watch what I'm doing, x minus 5, and then I have to double up on the parentheses. In the bottom, I have to put in a 3, and then x minus 3, like this, and then x minus 2, like this. So you can actually do a sign chart with your graphing calculator. Because I'm gonna graph that, and I'm gonna do this like this, because it just saves you a little bit of time if you do it this way with your technology. So I've got everything put in. So I'm gonna just do a zoom 6 on this. So basically, this is what this is telling me here. Okay, if you look at this, what's happening when you're below 2? What's happening? You're below the x-axis, right? So you're going to be below there. How about between 2 and 3? What's happening? You're above, okay? And then how about from 3 to 5? Looks like you're below, okay? It's a little hard to tell there until you actually go through and crunch that out. So one thing I can do, see, I can do my test points like this. I mean, you can look at your graphing calculator, but if I put like a 0 there, if I just traced at 0, that gives me a negative value, okay? That saves a little bit of time, doesn't it? Okay? Now, if I do a test point here, like a 2.5, so if I just trace at 2.5, you can already tell it's above the x-axis, but that's what you're doing, so that would be a positive. If I put a test point of 4 in there, trace at 4, okay, that'll clearly give me a negative. Sometimes you can't tell just by looking. Now, if I take a test point out here like a 6, if I trace at 6, that's giving me a positive. I couldn't tell, but now I can tell, see? So I got it. So see, if you get in a crunch, and if you're doing your homework, you can do it this way. I want you to know both ways to do this, with and without a calculator. But man, you can do your sign chart fast if you do it this way, right? And then that way you kind of see how the graph's going anyway. So anyway, what you'd end up having is this was a less than or equal to problem. Now watch this real carefully, because this is the most common place that students mess up on this problem. Okay, so what you have is you ended up being less than 0 in these two places here. So that means you're going to be here and you're going to be here. This is where it gets real picky, so pay attention. Okay, first of all, it would be wrong to say negative infinity bracket 2. Does anybody know why? What's going on at 2? What? You have an asymptote, so you're undefined. So you cannot put a bracket there. Okay, that's why I tell you to put a U there to make it real loud and obnoxious so that you realize that, no, okay, at an asymptote I'm undefined. So even though that's less than or equal to, I must put a parenthesis. Does that make any sense? You have an asymptote, you're undefined. Bracketed, you're not including that asymptote. Now let's go to this one. Okay, so now most students, if they weren't paying attention, would do that. Bracket 3, bracket 5. Why is it wrong? The 3 is a parenthesis. How come? Because it's an asymptote. How about the 5? Can you put a bracket there? Yeah, because it's an x-intercept. It's not an asymptote. So what you have to do on this problem that's real picky is you have to do that. Okay? Does that make sense? That's the reason I put those U's there, is because, okay, you're not defined there at all. You have an asymptote. If you look at the graph I have in my graphing calculator, you're not defined there. Okay? In set builder, you would just write this like this. So you would just say set of x, and then you would say x is less than 2. Or then you would say 3 is less than x is less than or equal to 5. Okay, so I did want to do one problem with that aspect in it, because you got to pay attention to that. When you have a less than or equal to on a rational inequality, you got to be really careful. Okay, does that make sense to you guys or not? Okay, so asymptotes are not included. Okay, make sure that you don't include those. Okay, all right, so that's all I'm going to do on that. So I'm going to close this off. Let's go ahead and take a 10-minute break.